Good morning. This is Ms. Billerbeck, and we're going to talk about 1.6 compound inequalities. A compound inequality is made up of two or more variables. So we have two conditions for a compound inequality. We have the AND situation. So this AND situation could look like this, where x is greater than n and x is less than m. So that's where it comes in play, but we can write it as n is less than or equal to x is less than or equal to m. So remember, you can just swap this one around. So this is the same as n is less than x. So that's how we're joining this together. Okay, so we have n is less than x is less than m. Okay, so you just keep the wide opening toward the x and you'll be fine. Okay. So then our next situation is the OR. So this one we have x is less than or equal to n. And this one starts, since it's got an equal bar here, this point is solid, it's included. So it can be n, or it could be anything less than n. This x can be m because it also has an equal bar, so we have a solid point, and it can be anything greater than. Now the reason why this doesn't continue on together, because m is going to be, x is going to be less than m, and it doesn't go on to forever here, and it doesn't go on forever here, because both conditions have to be met at once. Okay, so that means it has to be, x has to be greater than n, and it also has to be less than m. So that means that over here, it only fills one situation, but not both. So this area satisfies both the equations, so it's filled in. Now there is no equal bar here, so we have an open point. It's a fence around the point, so you can't ever be equal to n or m. Okay, but then these don't have the restriction. They can be both conditions at once because we have or. It could be this or it could be this, but both are okay. Okay, so that's why there aren't any restrictions on the or, but the and is restricted. It has to meet both conditions, or else it's not part of the solution. All right, so let's take a look at how we would write a compound inequality for this graph. So we see we have an open point here at 2, and we see that x is greater than 2. So we can have negative x is going to be greater than negative 2. So we see that. We also see that it's enclosed like an and. So we're going to write and. And then we have a solid point here, which means x can be equal to it. So we can put a bar there. But then x is less than 6, so we're going to put the less than sign here, and then 6. So we can write it like that, or since this is an and, sorry about that. Okay, but this is an and, so we have the other option of writing it like this, where I'm just going to flip this over, negative 2 is less than x. And so these are the same thing. I just put the x on the other side. So see how the openings with the x and the openings with the x there? So now I can write this in a nice simple way of negative 2 is less than x is less than or equal to 6. Okay? So this way is a higher level of representing the situation than breaking it up into the two different ones. Okay, so when we see this, we know we have an and. Okay, when we see this where it's constricted by 2 points and it's filled in between, it's an and. When we see this, we see, oh, that's an or. Okay, so there's no doubt about that. So let's write what this is. So we have a filled in point here, so 1 is included, and x is less than or equal to 1. So that's representing this side. Or we see we have 3 that's open, so x, it can't equal 3, but it's greater than 3, so x is greater than 3. So those two situations exist. Okay. So now let's solve the compound inequality, and we're going to graph it. So when we solve an inequality, let's pretend for a moment that this is an equal sign, and it's like a two-step. So we're pretending. So we're just saying, okay, it's like this. Okay, and then we're using an additive inverse to move that 2 over here. And we have negative 3x equals negative 9. Okay, then we're going to divide using a multiplicative inverse, divide by negative 3. And that gives me x equals, and then I have negative 9 divided by negative 3 is a positive 3. Okay, so now we go back to this equation here. So we did the hard work. So let's go back, and now let's put in the sign. So we have this, and we have this, but then, oh no, we divided by a negative number. So now we have to flip the sign. So then it becomes that. Okay, so we have that side done. Now, once we realize that this is just like an equal sign, we don't have to do this kind of substitution. So in order to keep track of when we flip, it's probably better not to do it substituting the equal sign. So now let's go back to this, and we're going to distribute that too. So we have 2x minus, and 2 times negative 2 is 4, and that's greater than or equal to 6. So we use an additive inverse on this side and an additive inverse here. Whatever we do on this side, we have to do it on that side. And we have 2x is greater than or equal to 10. So now I'm going to use a multiplicative inverse, and I'm dividing by a positive 2, so the sign does not flip. It stays the same. And I have x is greater than or equal to 5. All right, so now I can graph this. So it's a good thing to, if you have access to a straight edge, it's always nice to use one. So now when we graph this one does not want to make a nice point there. Okay, so let's graph this. So we have 3, and that's of interest, and we have 4 and 5, and that's of interest. Let me put the 4 a little bit over here. Whoops. There we go, and 5. All right, so the 3 is an open point because it's not included, and x is less than. So if we were to write 1 right here, 1 is definitely less than 3, so we want to go draw this direction here. All right, and then we see x is greater than or equal to 5. So that means x can be 5. So we are going to make a closed point. Okay, and then if I have 6 right here, that's definitely greater than 5. So that means we're going to shade in this area. Okay, so that's what an OR would look like. Make sure that that's a nice open point there. And then because 3 is not included with an equal bar, and then that is equal to, so we have a closed point. And this is definitely an OR situation because they go opposite directions. So that's what an OR looks like. All right, let's look at this situation. So again, we're going to distribute this negative. So we have, that's going to move there and there. So we have -2 times x, and then -2 times 1 is -2, is less than 4. So now we're going to use an additive inverse and move that 2 to the other side. And we have -2x is less than 6. All right, so now we are going to divide by a multiplicative inverse of 2 multiplying with x. So we're doing a division to cancel that -2 out. And when we divide by that -2, we, of course, flip. So now our sign flips over like this. And then this becomes x, and this side is -3. 6 divided by -2 is -3. All right, here this side, we're just going to use an additive inverse here of -1 and -1. And we have 4x is less than or equal to a -3 plus -4. It's like having -$3 in the bank and you spent another dollar. You are more in debt. So it's -4. Okay, we are going to use a multiplicative inverse. 4 is multiplying x, so the opposite operation is division. So we divide by 4, and we get x is less than or equal to a -4 divided by 4. We only have one negative, so it doesn't cancel, so we have -1. All right, so let's graph that. Okay. Now it's saying an and situation, so let's see if we do it right. If we did this the right way, it would show an and. Okay, so we know we have a point at -3 and -1. So let's put -3 right here, -2, -1, and we have 0 and 1. Okay, so we have x is greater than -3. It doesn't equal it, it's just greater. So let's put an open point right here, and we'll kind of open that up like that. So we have an open point, and then because it's greater than 3, it's going to go this way. Okay, and it's going to go on forever that way. Okay, this one is x is less than or equal to -1. So because it's equal to -1, -1 is included, so we can use a solid point. And this one, x is less than -1, well, -2 is less than -1, so it's going to go this way forever. But the only two places that it overlaps is right here. So it only overlaps in this zone here and here. So because it has to satisfy both the conditions, because it's an and, that means we don't just draw out the whole line with one open point, okay? So we can fill this in, and that is our and situation. Okay, so it has to satisfy both those conditions to be the solution. Can't just be one of the solutions. All right, so here's our real life problem. Fortunately, I've never had a heavy dog, I'll say, but I certainly have had a few heavy cats. And boy, are they cute. Okay, so, oh, and before I do that, I forgot one thing on this last example. Let's go back. So remember I said that you could write it like this and write it like this, but the very cool way to write it is like this. So when it's an and situation, this is the coolest way to write it. Okay, it shows that you have a high level of math education if you write it like this. So you want to write it like this, okay? All right, so, and that definitely shows it's an and, okay? All right, last example, back to the dog that we do not want to be heavy. Okay, so let's see. Okay, so River the dog eats between 500 and 540 calories per day. River eats 1.5 servings of dog food. That's 320 calories per serving. If her dog treats are 10 calories per treat, how many treats can she eat and remain in her calorie range? And that svelte little dog that she is. Okay, so we have a range of calories. So it's between 510 and 540. Okay, so between, typically when it says between, it doesn't include, but it's a real life problem, so this would include. So I think the verbiage should be just a little different. So it's between 510 and 540. Okay, so it can be anywhere in here, and our dog River will be happily fed, and not too much and not too little. Okay, so now we have to figure out, using that graph, what we can feed the dog. Okay, so the dog's food is 320 calories, and River, the dog, likes to eat 1.5 of those servings. So we can multiply by 1.5. So when we do that, we have 320 plus half of 320, which is 1, and that carries 60. Okay, So we add those two. So that's the fast math of how to multiply by 1.5. 1 times 320 and half. Okay, so our total then is 0, and then 2 plus 6 is 8, and 3 plus 1 is 480 calories. Okay, so already the dog food is that. But we know that our range is 510 is less than or equal to x is less than or equal to 540. And the treats are 10 calories each. Okay, so we want to subtract 480 from this and subtract 480 from this side. Okay, and then when we do that, we get 30 calories here. And this side, we get, and we're going to carry a 1 here, so that's 60 calories left. Okay, so then we know that the treats are 10 calories each. Okay, so that means that we divide, so it's 30 calories left, divided by 10 calories each on both sides. So that means the number of dog treats that we can have is between 3 dog treats and 6 dog treats. Okay, so River gets to have 3 to 6 dog treats a day. And River is going to be a happy dog. All right, so that is how you would do that type of equation there. So again, whatever you do on this side, you do on that side. Whatever you do on this side, you do on that side. So there you have it. All right, so that's it. You have a wonderful day. Bye-bye.